this video, we're going to look at what are called lists, which is another data type we haven't looked at yet, data from a file, and packages. So we're going to start out by talking about list. So previously we've looked at vectors, matrices, arrays, data frames, and what we saw that each of those had some restrictions to it. So for example, if we look at vectors and matrices, when we compose those objects, they either have to all be numeric or they have to all be characters. So we're restricted in that sense. When we looked at data frames, we saw that a data frame was restricted and that each of the columns had to have the same number of elements in it. Now we could have some columns that were characters and some that were numeric, but they had to have the same length. A list, on the other hand, is an ordered collection of components, but it's going to be a lot more flexible than a data frame. Now, majority of the time, you're probably going to be working with data frames, but you might come across an occasion where a list would be useful. So let's look at a couple examples of list. So as always, starting out here in my RStudio, I've got my module 3.2 script open. I have cleared out my environment, my console, so we can start fresh. So let's just look at a very simple example of a list. So I'm going to make a new object. I'm going to call it A, and A is going to be a list. And so I create object A by using the list function. So notice I have list with open and closed parentheses. Everything that I put in the middle of those parentheses, those are going to be the objects that go into the list. So you'll notice that inside of these parentheses, I've actually made 3 different objects. And so the first object is name, and it's going to contain the character string Amanda. Glasses is going to be a logical piece, and so glasses is going to equal true. And then siblings is going to be numeric, and it's going to be equal to 1. Alright, so let's run this and make the assignment. And now let's just look what A looks like. So up here in the global environment, notice that we see A is a list of 3 objects, and if we click down, we can actually see what those 3 different objects are. So notice the name of the object appears here on the left, we have a colon, and then we have more about the object and what the object actually consists of. Now one thing to notice is here in the assignment, we did want to go ahead and name those objects. It makes them easier to call from the list. And then down here, we could type A and see what A looks like. And so notice what you get in the output when you call the list A is we actually get 3 different pieces. So notice at the start of each of the 3 pieces, we have $sign and then the name of the object, and then we have what the object contains or consists of. So one way that we can call the individual objects from a list of objects is to use the $sign notation. And you can actually use that $sign notation with data frames as well. So for example, if we call a $sign name, that is going to pull out that object name, which just consists of the character string Amanda. If we call the a $sign glasses, that's going to consist of true. We can also use the bracket notation to call elements of a list, but when calling elements from a list, we need to use a double bracket. So we'll call both of these. So notice A2 is going to give us the second object, and then A3 is going to give us the third object. This is a little bit different from data frames, matrices, and vectors where we used a single bracket. With lists, we use the double bracket. The reason for this is that remember a list is comprised of objects. So what we do is the double bracket tells R to call the object, and then we can actually use with that single bracket notation to call elements from the objects inside of the list. So it's kind of this nested way that we can think of that. So in this example, each of the components were of the same length, so let's look at an example that we don't have the same length for our objects. So I'm going to create a second list here. It's called B. Notice again, I'm using that list function, and then inside of those parentheses, I'm going to put the different objects that are going to comprise the list. So I have 3 different objects. The first one is just going to be X, which is equal to 0.78. The second object is going to be y, which is a vector of length 3 that's comprised of 4, 8, and 2. And then finally, notice the third object we're creating here. I'm actually going to use a function to create it. If you remember previously we used the R binom function. This one is very similar. This is the R norm. It's going to pull a random sample from a normal distribution. And so how the R norm function works is the first object is the number of random draws that we want from the normal distribution. So in this case, I'm going to draw 16 random numbers. If you'll recall from an intro stats course, all normal distributions are defined by their mean and their standard deviation. So the normal distribution we're going to pull from has mean 0 and standard deviation 1. In other words, it's the standard normal. So we can run this. Notice that B is up in our global environment. It is a list of 3 different objects, and we can see that obviously these objects have different lengths. We could not do this with a data frame. So this is one of the flexible pieces of a list. And so just like before, we could call different elements of B. We could use the $ notation to call the third element, or we could use the double brackets. All right. We can look at some functions in regard to the list that we've made. So for example, if we look at A, notice the length of A is going to be 3. So the length of a list is determined by the number of objects that are in that list. We can look at the structure. The structure will start out by telling us it is a list of 3, and then it will tell us about those objects that comprise the list. The class of A, we see that it is a list. And then names of A are going to pull the names of the different objects that are in that list. And we could see something very similar with B. Right. So that is just a little bit about lists. Again, lists are much more flexible than a data frame. Using lists, I find that it's most useful when I'm doing simulations. It's usually when I use that, not so much when I'm working with data. But they are really useful to know about in case you come across something you're trying to program that you need something more flexible than a data frame. All right, so we're going to jump to our next topic, which is setting your working directory. So at the very beginning of the course, one of the things that I really wanted you all to think about was file organization, where you're keeping your files. And one of the reasons that's important is because in R we can do what is called setting your working directory. So the working directory, essentially what it is it is a place on your computer, usually a folder, where you tell R, hey, this is the folder I'm going to be working out of. And so all of your data sets you can put in that folder, and it's a convenient way for R to know where you're working so that you can pull files easily from that folder. And then if you manipulate data and you need to save it in a new format, you can then save the files to that folder as well. So we're going to talk a little bit about how to set your working directory, how to call in data from that folder you've specified as your working directory, and then also how to write data to that folder as well. All right. So there are 2 different ways that you can set a working directory. There is menu-driven way or by command, and I'm going to show you both of these. So the first one I'm going to show you is the menu-driven way. So notice down here in this extra window, remember there's a couple different things we can do down here. One of them is the Files tab. And essentially what this is this can let you look at all the different files on your computer. So the first thing you're going to want to do is you're going to want to navigate to the folder on your computer where you've got, your data sets and where you're going to be working out of. So if you'll notice here on the right, there's this small button that's got 3 dots. This will actually open up the directory on your computer. So if you click here, you'll notice that you've got all of the different folders that are on your computer, and you can use this to navigate to the folder you want to work out of. Now I've actually already navigated there, and you can see that here in the path. So notice I'm working on my Google Drive. I've got UK classes, this is our class, notes, and then we're currently in Module 3, so I have a Module 3 folder. And inside of here, I have all of my files for this particular module. Now you don't have all these files because you don't need all of them, but you should have the script is saved in here, this module 3.2 script, your script for module 3.1. And then the data sets that I had you read from Canvas should be in here as well. So once you have navigated to that folder you're working out of in this window, the easiest way to set your working directory is to click down on this More and just click Set as Working Directory. And notice what that does is that is going to auto-populate a piece of code here in the console, and it automatically runs it. So now my working directory, the directory that R knows to work out of, is this folder. The other way that you can do this, if you want to do it just by command, is simply use this piece of code. So notice the function here is setwd, and so I'm just going to go ahead and copy this here. This will already be in your script because I'm going to save it after I make this video. But notice the function we use is setwd, or set working directory, and then the only argument I'm going to put in here is the file path. Now, one thing to be very careful about, especially if you're working on a Windows machine, if you go to copy your file path on a Windows machine, Windows uses backslashes to separate the directory, where R uses forward slashes. So just something to keep in mind. If you copy a path from a Windows machine, you will need to change those to be forward slashes. Alright, so now that we've set our working directory, we can actually call in some data. So if you have, let's say, a text file saved or a CSV file, whatever format your data is in, we can read it into R. Now, I will pause and say here, I typically work with CSV files, so if I have data that's saved as an Excel file, I will save it as a CSV and then read it in. In more recent years, R has gotten much better at reading in Excel files, and there actually are what we call packages to help you do that, and I'll talk about packages at the end of this video. All right. So a couple different functions to call in data. There's actually lots of different ones you can use. There's the read.table. There is the write.table. So read.data is going to read data in. Write is going to write data out. And then scan reads data into R from a file. All right, so there's different ways to use this, and I'm going to show you one down below. So we're going to look at data from Walmart. This is a real data set. You can find a description at this website here. And in particular, we're going to look at a data set called train.csv. It is comma delimited, and it does not contain missing values. So one of the things you want to be cognizant of when you read in data is you want to know if there's missing values and how those missing values are coded. Often in the arguments for the functions to read in data, there are going to be arguments that specify how you want to handle that missing data. It's also always a really good idea to at least have some idea of the structure of your data set, what are the dimensions, those types of things. So after we read in the data, we can do some basic checks. And if those basic checks don't look like they should, then something may have went wrong while reading in the data. So we're always going to want to check our data after we read it in. So I'm going to use the read.table function. Again, there are lots of other ones. There's like a read.csv. There's all kinds of different ways to read in data. We're just going to look at this one for now. So I'm going to assign a new object. I'm going to call it Walmart. I'm going to use the read.table function. Notice here I'm giving the name of the file in quotation, so train.csv. One thing to notice here is that I'm not telling R where on my computer this file is. The reason I don't have to do that is because I've already set my working directory. If I had not set my working directory, I would need to tell R where this file is. And then finally, I have to give it sep equals. That stands for separation. CSV files are separated by commas, and so I have a comma here in the quotations, and this lets R know that the data is separated by commas. There are other ways to delimit data. There are tab and space and other ways, but a CSV or a comma separated is the most common that I see. So let's read that in. Right. Notice now that Walmart appears here in my global environment. Notice this is a pretty big data set. We have a little over 400,000 observations with 5 different variables. And so I can click here. It will show me what those 5 different variables are. Now, let's look at just the first 5 rows. And then, of course, there's 5 columns here of Walmart just to see what that looks like. All right. So this looks kind of odd, so let's talk through what happened. Notice by default, when R read in this data, it knows that there were 5 different columns, and so by default it calls them V1 through V5. But notice if we look at the first row of our data set, the first row actually contains the names of the variables. So when we read in data, it's very important to tell R if that file that we're reading in has a header for the column. So in other words, are the variable names included? By default, R thinks that there are no variable names, and so it will include those variable names as part of the data set. So instead, the correct way to read in the data is we actually need to add in another argument, which is header equals true. So now if we run this, it's going to overwrite the Walmart object, and now notice that I actually have in my variable names. I can check my data, and this looks correct. And notice if we run class, we see that Walmart was read in as a data frame. And so just as a reminder, recall that a data frame has the following properties. Each row must have the same number of columns, and each column can be a different data type, so similar to a list. This makes data frames more flexible more flexible than a matrix, but not as flexible as a list. All right, so what we're going to look at here is we're going to look at that comparison between a matrix and a data frame just as an illustration. So we're going to read in another data set. This is called made up data. So we're going to run this. Let's look at what this example data looks like. So we see it has 5 variables and we have 5 rows of data, and we see that it was read in as a data frame. So notice if we run this next command, it's going to return an error. And the reason for this is remember last time we talked about matrices and matrix multiplication. So I'm trying to perform matrix multiplication on a data frame, so that's not going to work. So this is what I was talking about in the last video of we have to be very careful when we use functions or different operations and make sure that we are performing them on the correct data type. If you have the incorrect data type, you can usually coerce the data into the correct data type. So for example, if we wanted to coerce this example data into a matrix, we could use the as.matrix function. So notice Y is the matrix version of our example data, and now we could actually run that operation and it would work. And then we always want to check the coercion to make sure it was successful. So in this case, we can use the is.matrix function, and we see that it did change it. So you'll see these for different types. There's as.vector, matrix. We can do the coercion. So the as dot whatever type, that's going to do the coercion, whereas the is version of these functions is going to check and see if it is that specified type. All right. So if you have if your data has columns that are different data types, we do not want to try to coerce R into giving you a matrix. A data frame is exactly what you want. Because remember, if you have a matrix, they all have to be characters or they all have to have numbers. So just keep that in mind. And I've been a little cavalier here when I say data types. I've been using it interchangeably to mean vector, matrix, array, list, a data frame, and then also within those objects, are we working with numerics or are we working with a character? So now again, we're going to go back to that Walmart. Remember we read that in as a data frame. And so here we can look at the structure of Walmart, get a little bit more information than we did with the class function. We see that it is a data frame. We see that again, it's comprised of a little over 400,000 observations of 5 variables. We can see what those 5 variables are, and then we get kind of a glimpse of what they contain. So if we use the read table with a vector of numbers, then we need to be careful about recovering the vector instead of a matrix with one column. So here is just another, I skipped this section right here. Let me back up here. So if we were to try to coerce this data into a matrix, notice that Walmart has some different types of data here. We do have logic, number, and we do have characters. So if we try to coerce this into a matrix, it will turn it into a matrix, but notice that this matrix, everything is now going to be characters. So we do want to be careful there. All right. So if we use the read.table with a vector of numbers, then we need to be careful about recovering the vector instead of a matrix with one column. So by default, when R reads in a single vector of data, it will change it over to a matrix. So let's look at an example here. So again, we've got another data set that you have, it's made up vector. So we read this in. Let's look at what D looks like. So we can see that D has 15 observations. It is a single vector. If we look at the class of D, we see it was read in as a data frame, and the length of D is equal to 1. But remember, we wanted to read it in as a vector, not a matrix or a data frame with a single column. So if we ask R, is it a vector? R tells us no. So again, we can use the as.vector function to coerce it into a vector, but we see it is still not a vector. So actually what is happening here is the coercion did not work the way we wanted it to. So for this situation, and it doesn't come up that often, but it is something to be aware of, so you could come back to this. You can either keep the first column of D or use the function unlist. So we're going to use F is equal to unlist D, and notice it now is a vector. Or we could just call the first column of D, and that sounds kind of silly because it's the only column of D, but we can run this and we can see again this is a vector. And then here is one other option just so you can see that. So notice here there are 3 different ways to achieve the same option or the same outcome. This is going to be very true with R, so always keep that in mind. Anything that I show you, there's probably 10 other ways to do the same thing. And then here's just one more. So just a kind of a note here, talking about the objects in R, here's a couple handy functions. So the ls function with no arguments in it, if we run this, this will show all of the objects we currently have in our global environment. And so here, if we look at our global environment, we can see, all of those things that are listed there are also here in our global environment. We can use the rm function to remove objects from our global environment. So let's say I wanted to remove lowercase d. You'll see that right here under values. If I run this, notice that d disappeared. And if we run ls again, d is now gone. All right. So that's just a little bit about reading data into R. Now let's look at how we could write data to a file. And again, keeping in mind, we'll want to have our working directory set. So if you're unsure if your working directory is set to the correct spot, or if you've even set it at all, you can use the getWD function with no argument. So if we run this, notice it gives me my working directory. Alright, so what I'm going to do is I'm going to take my Walmart data set, I'm going to manipulate it just a little bit, and then I'm going to save it as a new file. So let's say that I'm interested in those weekly sales from Walmart. So notice here I have Walmart $ weekly sales. If I just run that little piece, notice it gives me all those weekly sales. Again, remember that this was over 400,000 lines of data or rows of data. So R actually does have a maximum that it can print in the console. So that's why we're getting this down here. But let's say instead of weekly sales, I wanted to work with the log of the weekly sales. So I'm going to define a new object. I'm going to call it sales.log, and I'm going to set it equal to the log of weekly sales. So let's run this. And then, notice that I do have an error here. So let's see if we can figure out why I have that error. So if we go to my Walmart object, notice here, if I look at weekly sales, I can see that weekly sales is saved as a number. So that would be my first thing to make sure, I didn't accidentally save this as a character. So that tells me that I've got something else wrong here. So my next thing to do when I check this error is I'm going to actually look at sales.log and see if I can see what it looks like. So I can click here. It tells me a little bit, but if I look at sales.log. Let's just print some of them. This will print the first couple that it can. And I noticed that most of these look okay, but I am getting a couple NaNs. So notice that this NaN corresponds with the 847th observation. So what I'm going to do to check this is I'm going to actually pull, I'm just going to copy this piece, Walmart weekly sales. Okay, so, and I want to look at the 847th. All right, notice that this is a negative number. And just to kind of, remember that we can't take the log of a negative number. So that's why R is defining this as NaN. Now, this is just for illustration here. So we're going to say that that is okay and just leave that as the NaN. But if I were actually analyzing this data, that's something that, I would want to look into and ask, is it really appropriate to take the log of this variable, or do I need to do something else? All right, so the next thing I'm going to do is I'm going to combine both the Walmart weekly sales and the log of the sales. So I'm going to combine those two together. So what this is going to do, remember that cbind combines two columns together. So essentially I'm making a new data set that has two columns. One column with the weekly sales, one column with the log, and I'm going to name it data to write. But remember, you can name your objects whatever you want to. So you could have called this whatever you wanted. All right, so again, we binded those together. So the next thing I want to do is I want to look at the column names for this new data I just made. So notice that the column names, the first one doesn't have anything and the other one is sales.log. Well, I want my data set to have names. So I'm going to use the column name function again, but instead of just calling it, I'm actually going to use an assignment operator and say what I want the names to be. I want them to be sales and log.sales. Right? And now we're going to print out the column names again. And we see that now we have names for both of those columns. And so this last piece right here, this is actually the function that's going to write that data. So let's look through it. The name of the function is write.table, and then there's several arguments we're going to give it. The first thing we're going to give it is the data that we want to write. The second one is the name of the new data set. We're going to save this as a CSV, and I'm going to call it logdata.csv. Now, one important thing to note here. See, I've got my file open over here, and notice that that data set does not exist over here. Quote equals false. That's whether or not to put quotations around the data. Remember, that is important when we're reading characters. Column names equals true, because we did give it column names, but we didn't give it row names, so that's going to be false. We are going to separate this by columns because we want it to be a CSV. Append equals false because we're not appending this to a data set that's currently in the folder. And then we're going to use NA to use for missing values. So let's run this. And notice now in my folder I have a logdata.csv, and you could open this CSV in Excel or anything that you wanted to. It's a regular CSV, and if we were to open this, we would see that that data set contains two columns, one with the sales, one with the log sales. All right, so the last thing that I'm going to talk about here is libraries and packages. So we spent some time talking about base functions. So those functions are available just whenever you install R on your computer. But that is just a small fraction of the actual functions that are available to you. There are many what we call contributed libraries that can be downloaded and called into R that extend that base package that we see. And as we work in the course, we're going to use lots and lots of packages. So for example, let's say we wanted to generate data from a multivariate normal distribution. If you don't know what that is, don't worry about it. The point is, this is something that we want to do, and we have looked on Google, and we found that there was this function we could use, mvr norm. Okay. So we run this and we get this error. It says I can't find this function. Anytime you see the error that says could not find function, more than likely one of two things has happened. Either you've spelled it wrong or the capitalization's wrong, and in this is not the case here, or that function exists but you haven't downloaded the package to actually use that function yet. So if that happens, one thing that you can use is the double question mark. So if you put double question mark MVR norm and we hit enter, all right. Now this happens to me sometimes. If you ever get no search results, I'm not sure why that happens, but that does happen to me occasionally in R. If that happens, I just go to Google and Google MVR norm. But so try that on your own. Pause the video here. Google MVR norm function in R, and if you'll do, you will see that it is part of what is called the mass package. Okay. So again, MVR norm is not included in the libraries that Base includes by default. It is part of what we call the mass package. So to make the MVR norm function available to you, what you need to do is call that package. And so you can do that using the library function. So notice here, I call the library function, and then now I can use that function. So we see that here. Now there are some packages that are pre-installed on your computer, like the mass package. It just isn't called into R yet. There are other packages which are called contributed, and they are available on what is called CRAN. It's the Comprehensive R Network. Sorry, the Comprehensive R Archive Network. Alright, and so these can easily be downloaded and installed on your machine. So if you're pulling a package from CRAN, and there's going to be a lot that we need from CRAN, it's actually a two-step process. The first one is to install the package on your computer, call the library, and then you can use the functions in that package. So there's two different ways to install packages. The first one is to run the install.package function, and notice here I've just generically put package name in the middle, and then you would call the library with package name. The other way to do this is to actually click on Tools, Install Package. And this is typically what I do. One of the reasons that this is nice is it will autofill for you. So for example, a package we'll use a lot in this course is ggplot. So if you type in gg, notice it starts to autofill here. And so we're going to want ggplot. It's actually ggplot2. And then you could click Install, and it's going to auto-populate that code for you right here. But either way, you're going to get the same thing. You'll notice here in that example, a little pop-up came up. That's pretty common. Some of the packages are pretty large, and it'll take it a few seconds to install. All right. So just as a word of cautions here, sometimes when you call in a new library, it's going to have function names that conflict with one another. So I've only had this happen a handful of times, but it's really good to be aware of it. So for example, let's say we were going to use the MATLAB package. So if we call library MATLAB, that's going to pull those forward. Oh, see, here it said error, there is no package called MATLAB. If you get that error, that just means you need to install that package. It isn't actually on your computer yet. So I'm going to do that here. Click install. And then click library, and so now it's going to be good to go. So let's say I wanted to take the sum of a matrix. Alright, so here's the answer here. The sum function that takes the sum of the entire matrix has been masked by a sum function written to reproduce the sum function in MATLAB. So this is different than when we looked at the sum previously, and that's because that function has been overwritten. So again, it's just something to be aware of if you install a package and then you use a function and you didn't get the outcome you expected. It may be that that package has a function name that has, overwritten the function that you're trying to use. Again, I've come across this very rarely when I'm working, but it's definitely something to be aware of in case that does happen. Now, each of the packages have nice, well, not each of them, majority of them will have nice documentation, and you can use them here in the help section, or you can go to Google and pull up that package's individual page. Alright, so that is going to conclude this video. As always, if you have any questions about this, please bring them to class on Thursday, send me an email, whatever is best for you, and I'm happy to answer any questions that you have.